Apologize, my notes actually got cut off. Okay, so we were over here again. So if we looked at something that had a pH of 4, its H concentration would be 10 to the negative 4th, which is still pretty big. Remember, low pH means very acidic. So look at the that actually means 10 to the negative 4th. The concentration of H's is still pretty high. Remember, that's a bigger number than, say, this. Okay, but look at the balance. If I multiply these two together, I will still get 10 to the negative 14th. All these are the same situation, but look, as you go down, look at the concentration of OH. Okay, again, 10 to the negative 4th is a bigger number than 10 to the negative 10th. Okay, because we're dealing with negative exponents, so you got to think backwards. The bigger the number is in the exponent, if it has a negative next to it, that's a smaller number. Okay, so now look at the balance of the H's and the OH's. There's always a nice balance, okay? But as we go down and the pH is higher, which is basic, okay? Which means it's basic. We have more base ions. Again, 10 to the 0th power is bigger than 10 to the negative 14th. But if I multiply these two values, I will always get this magical number. 1 times 10 to the negative 14th. Okay, so now we know that. There are formulas that you guys will be given during the test, but these are the essential formulas that you guys will have. And to be honest, they're all kind of saying the same thing. They'll kind of lead you to the same answers. It's kind of like circular, all these calculations, and you'll kind of see how. I'll go through like 1 or 2 different calculations with you. So again, let's just go through, let's say, something that's pretty basic. Let's go through number 2. What is the pOH of 1 times 10 to the negative 7th? Okay, so what I want you guys to recognize is look at NaOH, alright? So, let me get my paper here. I apologize. This is not the most professional way to do this, but I'm going to try my best. NaOH. Now, like I said, that's a base. Did you recognize that? It's a base. Because you see that OH ion right there attached to that Na? That makes it a base, that OH, okay? So let's write that down here. And what I want you guys to see, this doesn't mean you have to write it down on the test. I'm just showing you what this means. NaOH, the concentration of that guy, by the way, is, because it says right there, if the 1 molar solution, if you see molar, that means it's a concentration. Right now, that's 1 times 10 to the negative 7th. Okay, you don't need to write that. I'm just going to show it to you because look, remember NaOH, it's a very strong base that dissociates completely into what 2 parts? Think about it, okay, 2 parts, Na, and of course the OH minus ion. That's what makes it basic, the OH guy. And guess what? If the concentration of this guy was 1 times 10 to the negative 7th, when it breaks off, it means both these concentrations are 1 times 10 to the negative 7th. Did I confuse you? Let's just say this. If the concentration of NaOH is 1 times 10 to the negative 7th, the concentration of this guy is the same thing. Okay, it's like saying 30 hot dogs. Okay, if I had 30 hot dogs with the bun, if I separated the hot dogs and the buns, I still have 30 buns. Okay, get it? Because, you separate it up into different components. Okay, so it's like a hot dog. That's the bun, that's the hot dog, the Na is the bun, the OH is the hot dog. If I have that many hot dogs, if I separate them out, I still have that many buns and hot dogs, okay? Hopefully that makes sense. Okay, so anyway, that's the concentration of OH. 1 times 10 to the negative 7th molarity, okay? That is the concentration. Now, what I want you guys to look at is look at the question. What is it asking me for? It technically gives me the concentration of OH in brackets, and it also gives me pOH. Well, it doesn't give it to me, but it's asking for pOH. So what I would do is I would go back to the formula and see what 2 things, or I'm sorry, which formula has pOH and OH. I got number 3, and I got number 6. But this one solves for pOH, and that's what I want. So I'm going to use number 3. Okay, so here's what I'm going to do. pOH is equal to what again? Negative log of OH, so that's what I'm going to write. Negative log of whatever my OH was. Okay, if you write that, it's the negative concentration of OH. So here's what I'm going to do. I'm just going to put negative log, and I'm going to plug in my concentration value, which was what? 1 times 10 to the negative 7th. Remember, the 1 kind of insignificant, I don't need to look at that. The 10, the log, will cancel out. And then I have that negative sign left over. And the negative 7 will get dragged down as the new base number. 2 negatives make a positive. Ta-da! That's it. My POH is now positive 7. That's it. That's all I had to do. Okay, one last thing that I'm going to do now is probably like a 2-part question, which is this. Okay, so you can try any of these out, but the one that I really want to go through is something like this right here. Let's go through number 7, okay? It gives me the OH of a substance is 1 times 10 to the negative 6th, but I have to calculate the pH. Now, if you look closely, look at this. There's nothing with pH and OH in here. Look, that's H and OH, but that's not pH, okay? There's pH there, but there's no OH. If you look through all the formulas, there's nothing there. So what that means is I have to use 2 different formulas. So I'm going to try to play along, because look, I got pH, I got a POH there, right? And that equals 14. So here's what I'm going to do, okay? This takes a little bit of practice, but let me show you how I'm going to attack it. I'm going to solve for the POH here, using my concentration of OH. You're going to see why I'm going to do it. So here's what I'm going to do. I'm going to carve out a little space here, okay? POH, I know, okay, I'll just give it to you, is the negative log of concentration of OH. Okay? And I'm just going to solve for that. I'm just going to play around with these numbers. Okay, and let's see what the concentration is really quick. I think let's go back on that problem. It's going to be redundant, right? Oh, the OH of this substance is 1 times 10 to the negative 8th. So that's what I'm going to plug in. 1 times 10 to the negative 8, right? That negative sign is going to stay. That 1's kind of redundant, so I don't leave it there. I'll just cancel it out, even though it's still technically there. 1 times anything is just itself, right? The logs will cancel out with the 10, and it will drag down the exponent number, so it'll be negative 8. 2 negatives make a positive. So right now, I have a POH value, right? But I want pH. Wait a minute. If I looked at that, I just screwed around because I didn't know what else to do. So I just plugged in this random formula. But look, is there a relationship between POH and pH? Let's see. Anything with pH and POH? I kind of foreshadowed earlier because I know from experience. But for you, you got to play around with the formulas here. Look, pH and POH, there is a relationship. If I add them together, I get 14. So look, I'll just do this. Sorry to not confuse you with the other problems. pH plus POH is always equal to 14, right? That's good. Do I have a POH value? Oh, yes, I do. I just plug in that 8 for the POH there because I have a POH of 8. I calculated that. What I don't have is my pH. So I'm going to kind of write X. I'll just say, like, I don't know what that is. So simply put, I'm just going to subtract both sides by 8. And then my X is 6. And remember, my pH and X, that's my pH. So my pH was 6. Okay? Alright guys, I'm going to leave you there. I'm going to, hopefully you guys can practice this. It's not as hard as it seems when you guys start practicing it on your own. But hopefully you guys will have enough tools to understand what pH and POH is, okay? Alright, good luck guys. Have a good night.